Tonight we're going to be studying linear inequalities. So our goal or our lesson objective is to be able to graph linear inequalities. So by the end, I want you to say, I can graph linear inequalities. First, let's define what a linear inequality is. A linear inequality is a linear equation that has replaced the equal sign with an inequality symbol. That's less than, greater than, less than or equal to, and greater than or equal to. Those are all inequality symbols. A linear inequality, let's talk about their solutions. The solution of a linear inequality is any ordered pair that makes the inequality true. And let's look at an example. Y is less than or equal to 2x plus 5, and we want to know is the point 2, 6, that ordered pair, within the solution. Well, we've got a x value and a y value, so simply let's substitute. 6 is less than or equal to 2 times 2 plus 5. Working through our algebra, 6 is less than or equal to 4 plus 5, or 6 is less than or equal to 9. That's a true statement, so the ordered pair 2, 6 is a solution. Let's take those skills and now we can graph a linear inequality. Well, step one for graphing any line, including linear inequalities, is to solve for y. We want to get into the form y equals mx plus b. So solve the inequality for y. Now, some common mistakes. Remember, with inequalities, multiplying or dividing by a negative will flip the inequality. It's very, very, very important that we remember those rules. Once we have solved for y, we're going to graph the boundary line. The boundary line for an inequality is just like that of a line of a linear equation. However, boundary lines have some special rules. First, when we're using symbols such as less than or greater than, we use a dotted line. If we're using the symbols less than or equal to, or greater than or equal to, we use a solid line. Graphing the boundary line. We've already solved for y, so we have the form y equals mx plus b. We know the pertinent information. First, it's less than or equal to, so that means a solid line. We know that the slope and the y-intercept are 5 for the y-intercept, 2 for the slope, and now we can graph it. And when we graph it, we're going to have a solid line that goes through the y-intercept of 5 and has a slope of 2. However, linear inequalities are a little different. It's not just a line. Inequalities have some shading above or below the line. The shaded area is called a half plane. For this equation, it reads y is less than or equal to 2x plus 5. The less than or equal to makes it a solid line for my boundary, but the less than indicates that all of the values below this line satisfy the inequality. And when we shade, we'll see just that. A good way to check is to pick a point that is within this shaded region here. I'm going to pick the point 0, 0. When I plug in 0 for x, I get out 5. Is 5 greater than 0? Well, yes, it is. So we know those are solutions. Notice the differences. We have two inequalities. They look very much the same. Y is less than or equal to 2x plus 5. Less than or equal to, I'm going to have a solid line. The less than tells me I'm going to shade below it. I also have y is greater than or equal to 2x plus 5. Greater than or equal to tells me a solid line, but I'm going to shade above it with the greater than. And you'll notice it's the same boundary line, but the shading is in opposite directions. Boundary line differences. Well, less than or equal to, greater than or equal to. We see that or equal to, we should think solid lines, because the points on that line are also part of the solution set. Anytime we have or equal to, the points on the boundary line are part of the solution set. But what about less than and greater than? Well, the boundary lines here are dotted. It indicates that the points on the line are not part of the solution set. A dotted line indicates the points on the line are not part of the solution set. Let's put it into action. I want to throw my 8th period class a party. I'm willing to spend $60. We know that pizza costs 12 and sodas cost 3. We want to write an inequality that describes this situation. Well, let's look at some of the important information within the problem. At most, $60. At most. Well, that sounds like an inequality. Pizzas cost 12 and sodas cost 3. So looking at this, pizzas cost 12, okay. 12x, where we would say x equals pizza. And then we have soda. Soda costs 3. So if x was pizza, y would then be soda. Good. And that at most $60. I'm willing to spend less than $60. I don't even know if you guys deserve $60. Kidding, of course. But less than or equal to $60. The most I'll spend is $60, but I will spend less than that. So 12x plus 2y is less than or equal to 60. We know how to solve. We subtract 12x. If you do it to one side, you have to do it to the other. We're going to divide by 2. And we end up with y is less than or equal to negative 6x plus 30. When we graph it, we'll see that we have a solid line because of the less than or equal to. We're shaded below the line because it's less than. We have a y-intercept of 30 and a slope of negative 6. Perfect. Now, why is this graph only in the first quadrant? Well, we know that our y values and our x values can't be negative because we can't have negative soda or negative pizza. So, homework tonight, visit my website. On there, you'll see a Google form. I want you to complete the Google form. Come in tomorrow ready to discuss how we can graph linear inequalities. Have a great day.